So this is the corpus callosum. Here is the pituitary. Here is the fornix. And here we have the brain. From this, there is the pineal gland. Then there are the superior and inferior colliculus of the midbrain. And here is the pituitary gland, the hypothalamus, and the peduncles of the midbrain. We'll rub off because we are seeing this midbrain here. Then there is the pons. So this is the pedicle from the midbrain. Here will be the two pedicles, right and left, from the pons. And then there is the medulla oblongata, and the third pedicle, inferior pedicle, will come from the medulla oblongata, and there will be the spinal cord. So this is the basic diagram. And the cerebellum is basically mounted on these three pedicles. So we are now studying the cerebellum. Cerebellum is the secretary of the cortex. And from the cortex, it finds out the position through cortico-pontocerebellar tracts. It finds out the intention of the cortex. Intended position of the body at time t. Okay. And now it sets to work. The first thing it has to additionally find out is what is the present position of body. At what rate it is changing. And if you calculate these two, then you will be able to say expected position of body at time t. Then it has to simply subtract the intended from the expected, find out what is the correction needed, and get it done through the extrapyramidal system. Which controls muscle tone, the flexor, extensor tone through a stretch reflex. So the ability of the stretch reflex is that if the elbow is flexed 30 degrees, the stretch reflex is able to equalize, and the flexor and extensor tone at 30 degrees are equal. So the stretch reflex would be able to say that no, now the flexor extensor tone will become equal at 40 degrees. So it can tell you the exact position at which the movement will occur and the elbow flexor extensor tone will stabilize. So this is the importance of stretch reflex. If you try to stretch more than 40 degrees, it will return back to 40 degrees. So after understanding this much, let us try to find out what information does the cerebellum need to find out the present position and the rate of change. The first position is from the eye, artificial horizon, comes to the tectum, and from the tectum, tectocerebellar tracts. So these are tectocerebellar, conveying information from the eye about artificial horizon. The second is information from the semicircular canals, the semicircular canals of the ear, which says what is the present head position and what is the rate of change of the head position, in what plane, and how fast. So these semicircular canals convey this information through the vestibular nucleus, and therefore these fibers will be now called as vestibulocerebellar. Then the third method by which the information would come would be from the spinal cord. Basically through the inferior cerebellar peduncle, and some fibers rise up to the midbrain and come through the superior cerebellar peduncle. Now, what is the information from the spinal cord? Present position of joints, all joints. Information coming from fasciculus cuneatus. Goes up to the medulla and enters the inferior cerebellar peduncle. Then rate of change of position, change of joint position, that is fasciculus gracilis. They are also called as posterior column, or they are also called as columns of Gall and Burdack. Then basically muscle tone, that is carried by spinocerebellar tracts. We'll rub this off. Cerebellar tracts. The anterior ones rise up to the level of midbrain and go to cerebellum of opposite side. The posterior ones go right up to the medulla and go to the cerebellum of same side. So through these tracts, now you clearly know what was the intended position, what is the expected position, and how much correction is to be applied. So the cerebellum gets connected to all areas of extrapyramidal system. Let us make those areas quickly and you learn to also draw the coronal section of the brain. So here is our corpus callosum. Here is the septum lucidium. Here is the fornix. Here is the thalamus, the third ventricle in between. This is the thalamus. Here is the caudate nucleus, the lentiform nucleus, the fibers in between the two, this triangular nucleus is lentiform nucleus. Outside is claustrum. So this component is internal capsule and this is external capsule. And then we'll make quickly the cortex 1, 2, 1, 2, the lateral fissure and insula here, temporal lobe going to the midbrain. Okay. We'll make it a little bit more symmetrical. This is the midbrain. So there is the midbrain. Then there is the pons. And then there is the medulla. And finally there is the spinal cord. So let's see. Here there is area 4S. Cortex area 4S. Then nothing in the between the internal capsule and this. Then you have the caudate nucleus, the lentiform nucleus, the the claustrum, and the insula. Then at the level of the midbrain, you have the red nucleus, the substantia nigra, and reticular formation. At the level of the pons, you have the vestibular nucleus and reticular formation continued. At the level of the medulla and spinal cord, at the level of medulla, reticular formation continues, but at the level of spinal cord, the same reticular formation becomes the internuncial neuron system. Now, something which is very peculiar about the reticular formation is this, that if A stimulates B and B stimulates C and C stimulates D and D stimulates A, and when the impulse it returns to A, the A is not refractory, then this impulse will start going round and round like this. Perpetually it will start going round and round. And at each point, if there's a neuron which is going out, you will have an electric impulse at a fixed frequency, depending on the size of this oscillatory circuit. So this is the peculiarity of the reticular formation and the internuncial neuron system. Now there are two basic types of fibers which descend from which are capable of producing muscle movement. One are voluntary. They are called as pyramidal. And the second are corrective. Run at the behest of the cerebellum. They are called as extra pyramidal. Now we'll show you a particular structure of the muscle which is responsible for the stretch reflex. The muscle fibers consist of nucleated intrafusal fibers and extrafusal fibers, which run from origin to insertion. Now, as the origin and insertion comes closer, the muscle is contracting. And basically, this origin and insertion is both on the flexor side of the joint and on the extensor side of the joint. So this is on both the sides. So now what happens is that this intrafusal fiber has got an annulospiral ring in the center, and it has got muscle fibers on both sides. The alpha neuron supplies the extrafusal fibers, and the gamma neuron supplies the intrafusal fibers of both sides. Now, supposing the extrapyramidal system is desiring to bring this origin closer to this insertion, then it will stimulate this gamma neuron. It will stimulate on both sides, on the flexor and extensor, both sides. And what will happen? That these intrafusal fibers will contract and the distance between the annulospiral ring will increase. This would be conveyed to the spinal cord through the posterior column. By a bipolar neuron, it will get connected to the alpha neurons. So here is the extrapyramidal system, and then the extrafusal fibers will contract so that origin comes near to the insertion and the distance between the annulospiral ring is restored. So it may have been initially at 30 degrees of flexion of elbow, but now it will be restored at 40 degrees. So this mechanism of stretch reflex is able to control the position of the joint, which is intended exactly by adjusting the relative tone of the flexor and extensor muscles. I hope you have understood the stretch reflex, and you tested that if you stretch the muscle, it will regain its original length. So I hope this is useful.